Okay, good evening everyone and welcome to another of my live streams. This is the 101st live stream, so I'm happy to be here, I'm happy to have everyone here, and I'm happy to have my moderator here. Today is going to be Foxtrot Charlie, who you did meet on the last live stream, since the last live stream, the 100th one, was basically a discussion panel slash questions and answers hour for my whole team, almost my whole team, since Maryush was not there. He was on the Polish live stream on the chat, but but the rest of the team, KrzaQ, Foxtrot Charlie, disconnected, were there. So you finally met my moderators. Today we are back to business, back to the usual business of PicoCTF, which has been the topic of the last, I guess, 10 episodes. Well, actually, this is the 10th episode, or is it the 9th? It's the 9th, so we are not yet there, but close to it. It seems like eternity because there are so many challenges in the PicoCTF. That's just amazing. I believe we have solved already over 70 challenges, and I think there is still over 30 challenges, so yeah, but we'll get there one day. Welcome everyone. Happy to have you here, and let's switch to the usual announcements I do. We will start with the actual challenge solving, I guess, around 15 minutes past, quarter past, since I want everyone to, get here. And okay, and I do have a couple of announcements, so let's start with finding my browser. Where's my browser? Here we go. Okay, so foxtrotlabs.cc, this is the website of my moderator, today's moderator. Do check it out. Now, if you have any questions to me during today's episode, do ask this guy. Like, you can see his nickname here, Foxtrot Charlie, since he basically has the means to pass me the question. I sometimes look on chats, but if I'm super focused on the code or the challenge, then I just miss questions. Thankfully, Foxtrot is here, and he will grab your question and will put it on my question list, and I will be able to answer the questions from the list later on. Now, it's best if you actually ping Foxtrot Charlie, like, @Foxtrot_Charlie on YouTube or on Discord. Or if you're on our IRC, it's enough if you do !Q and then the question. So you do not have to ping Foxtrot Charlie if you're on our IRC. If you do that on Discord, by the way, the question will basically be anonymized, as it will still pop up in my question panel, but yeah, your nickname will not be there. So be warned. Perfect. Now, this is my blog. Perfect. I did upload recently a new blog post, which is how to document your knowledge in a CV/resume. This is basically a common question for people who are just entering the job market and are mostly self-taught, which means they learned programming themselves, learned hacking themselves, and now they're looking for a job. They, for example, might have a university degree or might not, but they have a lot of other stuff they did in the past. And this post basically talks about how to what you can put in your resume, what is perfectly acceptable. And this is actually this is one list, and the other list by people from my Polish side of the blog is in the bottom of that blog post. Now, I actually had this blog post published 10 years ago on my Polish blog, and I finally had some of my most popular blog posts translated, and I'm updating them and publishing them one by one. So this is the first one. And I do use this a lot when somebody sends me a resume to take a look, so that I can, suggest some stuff. This blog post is what I usually point out to, like, take a look at it, take a look at the list, think if there is something which you want to add to your resume, and yeah, so there is that. Cool. Now, paged out. Paged out is delayed. This is because of me. This is not because the magazine is failing. This is not because of COVID-19. This is basically because of me, because I'm retooling, like making basically one website where authors and reviewers can meet and can discuss and correct articles. And this has been a lot of code written by several people, and it's not yet there. It will be still a couple of weeks before we finish it. But after we finish it, the good thing is that it will work for years basically, and it will be super easy for us to make next issues. We already have over 50 articles for the issue. The issue number 3 will come out, and then number 4 we already have some stuff for number 4 as well, so don't worry, it will be there. But apologies for the delay, that's on me actually. Now yeah, but you can still, like, if you haven't checked out the issue number 2 or issue number 1, I totally suggest doing it. It's actually like pretty good, so absolutely check it out if you haven't yet. It's totally free, and there are a lot of one-page articles which are super technical, and like they're about hacking, programming, game development, and some other stuff, and hardware, for example. Absolutely check it out. I guess I'm going to leave you with the link. Yeah, and due to, well, the whole situation outside actually doesn't help, because we wanted to do test sprints, and finally the one thing which is missing here is the the print files. Where are the print files? And we kind of have them ready, but we want to do a test print, like the second test print before we publish them, and yeah, we cannot really send them now to the print house for the reasons outside, as you know. So that will be delayed as well, but I actually have an excuse for that. Cool. So, okay, our problems. I will not yet start with the problems, I will do the questions now. We have, yeah, as I mentioned, 74 solved, 25 unsolved. Do not trust this number. There are more challenges, more hacking challenges, which we will have to solve later on. That will appear later on as well. So let me show you some questions which are already here. We will wait around like 7 more minutes, and then we will start the actual topic of the day, which is PicoCTF part 9, and doing 1 or 2 challenges, depending on how many challenges we are able to do today. Cool. Perfect. So, question from Trapper. I believe that's actually a question from an older live stream, but it's fine to answer it here. How do you find a CTF team in an early stage of playing CTFs? I am currently playing alone, but I would prefer to chat with people. Is it enough to be good in one field to join a team? Do teams usually want to check what kind of challenges one has solved? Okay, so there is no single answer, but my take on it is find a team as early as possible. It doesn't matter if you just started. It doesn't matter if you've played already like 20 years of CTFs or whatever. I don't think there are people who played 20 years because, well, or maybe there are actually. In any case, yeah, but one thing you need to remember is that if you are just beginning with CTFs, you're probably not going to get to a top team. Like top 10, top 20 teams are probably... you probably will not be able to join them. You should be able to either join or create a team of people who are on a similar level to you, which is fine. Look around, ask around. There is, I believe, on the CTF Time website, there is even a dating part. Oh, by dating, I do mean here actually like looking for a team. So let's take a look. I think it's teams, yeah. Get team members. If you go there, it's actually called dating for some reason. I'm not logged in here, but yeah, if you would go here, you can find people to create a team with, and you can find teams which are looking for people, I believe, as well. So, and you can also ask around, as mentioned. Sometimes you can find a team, sometimes you cannot. If you cannot, think about creating a team. Think about, like, you create a team, figure out a name, figure out how to animate it, and look for people to join you and to play. But I fully recommend getting a team in CTFs, because it's like you learn together, you learn faster together, you solve more challenges together, you can get like first-hand knowledge from people who solve the challenge by just being on IRC and chatting them and giving them ideas. If they are stuck, they will be giving you ideas if you are stuck. So totally get a team as early as possible. Now, how does teams basically, do they ask for a resume? If you want to join them, do they ask for how many challenges did you solve, and so on? That depends strictly on a team. For example, in Dragon Sector, you are expected to play as a guest for some time. There are some other restrictions. For example, you do need to know fluent Polish because, yeah, we tried communicating in English, that doesn't work. So you need to know fluent Polish, and then you play as a guest until you prove that you can solve like high-level challenges during a couple of CTFs. And after that, you get an invite to the team. That's basically how it works for Dragon Sector. Some other teams might have, like, I don't know, some challenges which they would give you to solve. They might ask you which challenges did you solve, like for link write-ups, links to write-ups and so on. So that really depends on the team. And yeah, your mileage may vary, basically. Your experience may be totally different depending on what team you are looking for. Regardless, do look for a team. That's a good thing to do. Like, ask around. It doesn't hurt. Even if they say no, that's fine. Like, just ask another team. It's like looking for a job, basically. Like, you do not ask one company, they say no, and you, like, stop. No, that's like, you ask 100 companies, and some of them reply, and then you choose the one which suits you most. So, yeah, that's about it, I would say. Okay, have you heard about CodeQL? Any ideas, thoughts? I do not believe I did hear about CodeQL. What is CodeQL? Let's take a look. CodeQL, discover vulnerabilities across the code base with CodeQL. CodeQL, what is CodeQL? CodeQL query. Oh, it's lgtm.com. Yes, I did hear about them. Yeah, that's pretty amazing. Absolutely play with it. The language is weird. It's basically like SQL-like language, which allows you to do queries on code bases, including on data flow in codes. I did play a little bit with it. I did chat actually with people who made this, and this is pretty amazing. Like, I'm usually super skeptical when it comes to static tools for looking for vulnerabilities. This one is actually quite interesting. It's not an automated tool which will find all the vulnerabilities for you, but it allows you to write queries to look for a specific type of bugs in your code, or in code in general, as long as you are able to express the vulnerability in this written language. That's pretty cool stuff, by the way. I really like this idea. Now, what else can I say about it? Yeah, at the end, it still boils down to being able to express the vulnerability as a query, which isn't simple. And yeah, we did have some attempts, and basically, even if you take buffer overflow, it ends up with different possible instances of buffer overflow, and each one requires a separate query. Sometimes the queries are like half a page, and yeah, so it's not like it's a good tool, basically. It's not like a holy grail of security or anything like that. It is a good tool still. Cool. What's the time? Okay, we have still time for a couple of questions. Supervoid, Eridanus Supervoid asks, what is the best approach for reversing and exploiting huge stripped binaries? What is a convenient way to check how and in which way a program gets inputs from the outside? I'm sorry, this is going to hurt. There is no convenient way. Reverse engineering is a pain, especially if you have a stripped binary. Even worse, if you have an obfuscated stripped binary, that's a pain. I don't think there are any cheats to use here. At the end of the day, you have to spend a lot of time in IDA or Jidra or Radari 2, whatever tool you are using. But how to get inputs? Well, there's only a limited number of ways an application can get an input, right? That's either through some pipe, through some terminal, through sockets, or some other inter-process communication mechanisms, or network communication mechanisms, but there aren't that many of them. So if you start with a tool which shows you all interactions with the outside world, like strace, for example, and you tell it, hey, I want to just opens and or maybe read, write, receive, send, then it will, and there's actually an option for strace to show you the address where the instruction was called. So you can do that, and you can see where a given thing was called, and you can look in IDA and then like mark this function as, okay, it gets like input or output from the outside world, and then from that you work up in the code base. It is painful, especially in super large code bases, and there is no way around it. You have to understand what's going on there, but do focus on inputs and outputs if you're doing security research, especially on inputs, but outputs also, because everything else like config parsing or like, I don't know, like data parsing, which you cannot interact with in any way as an attacker, that's boring stuff for you. That's what should be avoided. So yeah, that's basically it. Another way is like there are some taint tracking mechanisms which you can use, or like not even that. You can use some trace mechanisms for that, where run an application, do everything which is not related to external output, external input, and save the trace, and then run the application again, and only touch whatever does the external input, like takes external input. Like for example, I don't know, like press a button which downloads a file from somewhere. And then basically you have two lists of traces, see what functions are on the second trace and are not in the first trace, and these are your functions which process the input. So that's another thing which you can do. Yeah, but at the end of the day, it's basically, you will still have to do a lot of code analysis, basically, because you will end up with functions which are super low level, and you'll have to work up to understand what's going on, how they are used on a high level code. That's a good question, but there is no easy answer for it. Do you need help with building the site you mentioned? Thank you, Shimon, for asking. Not yet. Basically, that's the answer, not yet. I need to finish the architecture first, like the whole framework, and then there are already a couple of people who are helping me or are in the pipeline to help me. Later, perhaps, because there will still be, yeah, I'm basically, after I have the basic side, we will start reviewing and getting the issue 3 out, and then there are still a lot of features we want to implement. So send me an email if you want to help later on. Vivek writes, is reverse engineering a good long-time profession? No. Depends. It's like this. From my perspective, okay? Reverse engineering is a tool which is super useful in several like job ladders, let's say it. If you are doing malware analysis, reverse engineering is the way to go. If you are doing security research, especially like binary level, then reverse engineering is a tool you need. And like if you are doing translating applications from one language to another language, meaning like, I don't know, from Polish to English, right, or the other way around, you need some reverse engineering as well to be able to like decode bitmaps, translate the text on the bitmaps, and then code it again. Sometimes you get that from the producer, sometimes you don't. So, and there are a couple of other cases where reverse code engineering is used, but at the end of the day, I would look at it as a tool. So it's by itself, if you specialize in reverse engineering, you still need to use it for some of these things. And usually, if you go for malware analysis or like security research, there's still a lot of other stuff which you have to learn. So by itself, no. But as a tool in malware analysis, as a tool in security research, yeah, sure. You have to know it, and you can be super good at it. You can specialize in it, but you still have to learn some other stuff, and you have to like have in your mind what are you going to exactly use it for. That's basically it. And like I only enumerated 3 different jobs which require reverse engineering. There are a couple of more, like anti-cheats, or like DRM and anti-DRM. Well, testing DRMs basically. So yeah, now yeah, and then you can work in a given job until you either are bored or like achieve everything, or forever, as long as you like it. Cool. 2 last questions. Adam writes, average amount of average applications for team. Good question. I have no idea, actually. I don't know. Like, we don't get too many, so, but I don't know for other teams. Diren writes, what would writing code for microcontrollers like the PiC16 help with learning assembler? Yes, sure. Do note one thing. For each architecture, the assembler is different. It's like if you understand, like by heart, understand one assembler, you will have like an easy way to learn every other assembler, but you will still have to learn every other assembler because they are different. Not super different, the ideas are still the same, but all instructions are different, all registers are different, how the memory works like might be a little bit different, or like really different in some cases. How registers work usually are the same, but there are some little details that you need to care about. So yeah, like if you learn one assembler for whatever, that's good because you then are able to understand assembler. After you understand assembler, then every other assembler is just learning the syntax and architecture difference. And it's good to do that because that kinda widens your general expectations of dealing with low-level stuff. And you can, I don't know, like you learn x86 and then you learn ARM and you see like, hey, in ARM I'm doing this like this. Can I do the same in x86? Or maybe does x86 have a feature like that which I never noticed? These are good questions to ask, and these are questions which come to your head after learning stuff which is not related to your main goal, just like some similar stuff. So that's yeah. I guess what I'm trying to say is don't stop at one architecture and one assembler, just go wider. Start with one, learn it, understand assembler, go for the next one. Okay, Burp Suit versus Zap Proxy. I actually use Fiddler. So, well, whichever you like. Like, I mean, all of these tools are good. Burp is amazing. Zap I used last time 11 years ago or something like that, so I'm not sure what's the state currently. Fiddler is cool as well, but it's a little bit different than Burp. Will you make a stream about binary instrumentation, static and dynamic? We might do it someday. Yeah, like actually Foxtrot, if you could add this to our topic list for someday. And I guess we can get going with today's topic, because we did clear out the question list. We are a little bit behind, but that's fine. Cool. Challenge problems unsolved. And yes, let's do binary stuff today. I'm going to still ignore this challenge because it requires me to set up my sound cards and get some other stuff which I never have time to do. So let's just like focus on binary exploitation, reverse engineering. We have a lot of them to clear up, so binary exploitation, let's go with GOT. You can only change one address. Here is the problem. This is the program. This is a binary program, so we'll have to read the assembler code for it, or rather the disassembler output. It is also found here, and okay, perfect. And we also have the source code, which is perfect. So I'm going to download this. I'm going to go here on the, I actually do have the shell already logged in, so I'm going to go there. And yeah, we have a typical setup where we have a flag, which we cannot read because it's, well, another group. Or can we read it? No, we cannot read it. We need to get this group to be able to read it, or this user. Thankfully, there is a, like, as JIT binary, set group ID binary. So if we run this binary and we somehow get code control or like execution control over this binary, we can force it to read flag.txt. And then we have the source code. So let's look at the source code first, and then we'll look at the disassembler output for the assembler. Let me just make the... Okay. Perfect. Now, this is the source code for the binary. What we have here is pretty short. Let's start with the main. There's some puts. You can just overwrite an address. What can you do? Then we input an address, which is in decimal form, to a pointer. A pointer is an integer pointer, that's fine. Then we input a value, and then the value is written. Is it written? Yeah, it's written to the pointer. So first we set the pointer, then the value is written to wherever we want it to be written. So this is called a write what where condition. Write what where, or dab dab dab. Sometimes we just say dab dab dab, and it's pretty common. Usually in exploitation, which is more tricky than a simple buffer overflow, what you want to do is you want to do stuff until you get a write what where condition. And having a write what where condition is usually pretty simple to abuse in a way to get some form of code execution. It's actually like having a dab 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 with known address space is like just one short step before achieving code execution. Now what's important here, we do not have a return, we instead have an exit. Do note this is an exit, this is not underscore exit, which are two different functions. The difference, which might be important here, might not, but might be important here, is that underscore exit would just exit the program. Now exit does not just exit the program, instead what it does, it calls all the destructors which might have been registered. Like for example, you might know the @exit function, which takes a function pointer, and that function pointer is then added to the destructor list. And the destructor list is being called when this exit is being invoked, basically, or when main exits, where main returns, then the same destructor list is being called. So this already kind of points me in a direction that maybe I want to write, like set this pointer somewhere in the destructor list, and then, yeah, then redirect the code execution somewhere else. Now we have the pointer and we have this win function, which basically reads a flag to a buffer and outputs the flag and flashes standard output and just returns. So yeah, what we need to do is we need to somehow overwrite one value in memory, probably with this win, address of this win function. This is what we have to do. It might be a little bit more complicated, but this is the initial idea, the easiest idea, and this is what I'm going to go for. Now, let's look at the disassembly. I'm going to use IDA as the disassembler, but you can use anything. You can use like IDA free, you can use like Hydra or Ghidra, whatever you want to call it, Binary Ninja, Radari 2. You can even use just a simple object dump, because it doesn't really matter for such a short code. Cool. What do we need? We need to take a look at a couple of things. First of all, I want to know if actually let's go here. I want to know what protections are in this binary. So I'm going to run checksec. Checksec says canary is found, non-executable bit is enabled, no PIE, basically no ASLR. So any address which I see in IDA, any address will be the same address in memory. This is what no PIE says, which is perfect. Now we need the address of the win function. So here's the win function. And this is the address of the first instruction of the win function. So I'm going to create a notes file so I can note this down. So win function is this address. Perfect. Cool. Now we need to find some pointer in memory. And as I did mention, okay, so it's like this. Main is not the first function which is executed when the program starts. Instead, well, the constructors need to run first. But apart from that, and you might be like asking, why am I saying constructors and destructors in C, where like constructors and destructors are actually thing of the C++ world? Actually, in C, in some compilers, you can declare some functions as constructors or destructors, and they will be run before main or after main. So just remember that some compilers allow it. And given that this needs to be processed first, main isn't called as the first function. Instead, there is a function which processes this, then processes main, and at the end of the day processes the destructors. Cool. So this is actually the function. It's called start. This is where the execution begins. And then we have, this is where we, well, basically call lib_start main, which is a library function which does what I just mentioned, then calls main, and then calls the destructor list and like exits. It never should return actually, so this is why there is a halt instruction here. Now, this stuff here is actually the fini and init lists are actually the constructor and destructor lists. So we can take a look there. Let's just go there. Okay, so this is just a return. This is, by the way, just a lia, so it's not jumping there. This is a little bit confusing. What does this do? This does, okay, then it adds. It's probably just like calculates the I'm not looking for this. I'm looking for an address which contains this, and this address might be... Oh, okay. We are not going to even have to play with the destructor list. I was going to look for the destructor lists somewhere in the binary memory, but instead we can just play with GOT. Well, the name of the challenge is GOT, right? Like, I'm not sure if you can see it, but it's GOT. GOT is a global offset table. It's basically a table of functions which are which are imported from other libraries. So yeah, this is the list of functions. Now, as you can see, there's something called exit here. This is the entry for the exit function, which is being called at the end of main. So it's called here. And therefore, what actually happens in Linux, because Linux has something called lazy loading by default. On Windows, it's not the case. On Windows, it's totally different. On Linux, however, it's lazy loading. So basically, if we would call a function for the first time, for example, puts or for example, exit, what actually happens is that this would go to a PLT. Where's the PLT? So this is got PLT. I'm looking for PLT. Here we go. Okay, cool. So this basically goes to a function, which function pushes some address. Okay, this is boring. Let's get a different one. This one. Here we go. Yeah, and well, this just jumps to the offset here. Initially, this offset is actually set to a library function which does the importing, and then the offset is being overwritten here. That's the idea behind it. Now, yeah, so yeah, basically, does that matter in our case? It sometimes does matter. It might not matter in our case. Let's see. So what we are going to do is we are going just to override the exit function. Main, this is the main, this is the exit. As you can see, the exit is basically just jump to this offset, which is here, and this offset is what we are going to override. So what we need to do is we need to set the pointer to this address and then set the value to win here, and that should be it. So we have this address. Now, as I did mention, okay, so this is the pointer. That might not work. It should work. This is a default way to do it, but let's see. Now, what is important is that we need a decimal number. And the decimal number would be, let's just run Python. Xbook, this is this decimal number, like the first one, and this is the second one. So OX something is converted to this value. Perfect. What is this, like 133 million something, blah, blah, blah. Cool. Let's run it on here. Input address. The address, we input the address of a pointer to override. And what value to override with. We want to put this pointer here. We want to write it here. So that when exit is called, instead, actually the win function is being called. And it was called, we did get the flag, which is the solution to the challenge, and the program crashed. But that doesn't matter at all. We do not care. We care only about the flag on a CTF. So that's basically it. Are there any questions to this specific challenge? I guess this is pretty straightforward, since what you need to know for this challenge is basically you need to know a little bit about how the binary after compilation looks like. You need to, well, here you just need to know about the import table, which is the .plt table in case of Linux, or like the import table in case of Windows, I guess. So that's the structure of a binary file. And if this wouldn't work, you probably would need to know a little bit about function pointers and where are some functions pointers which you can normally find. And that would be, for example, the destructor and constructor tables, which, yeah, I don't know, but they don't matter here, so let's not spend time on that. Are there any questions related to this? Oh, that's an excellent question from Albert. Is the .plt table always writable? So this is the plt god. This is the, as you can see here, is read-write, and the answer is no. It shouldn't be, and sometimes it even isn't. Depends on how exactly the binary was compiled, but there might be some code somewhere which basically just doesn't set the right attribute here, and instead, when you do .plt resolution, you change the memory to being writable for a second, and then change it back after writing the value from the, after resolving the import and writing the address of a function there, you change it back to being only readable. This is by default on Windows, or at least was by default on Windows, if I remember correctly. For some compilers on Linux, I think you have to add either some flags to the compiler or do some other stuff. Some distributions compile a lot of programs this way, but for some reason it's still pretty normal to find .plt writable. Now, do not trust this table here with about reads and writes, because this table, as you can see, is there an example I can use here? Yeah, here this is an excellent example here. So let's look here. It basically says that this from this address to this address, the stuff there is readable and executable. However, the next piece of code, this, like, how many bytes is it? Is like 30 hexadecimal, like 50 bytes, are not executable. And then the next section is again both readable and executable. This is what we can learn from this table, and this is false. Why is it false? Because at the end of the day, memory is, you can set attributes to memory in pages. So you can set a given attribute to a page, and a page is 4 kilobytes. So you cannot set an attribute to a byte. And here is like 50 bytes, which would supposed to have a different attribute, which would suppose not be executable at all. However, the operating system can only set this in like 4K, like 4 kilobyte pages. So it cannot select randomly 50 bytes and change the attributes for them. It can only change the attributes for the whole page, which means what actually is happening here is that everything which is on the same page, the attributes, the privileges of it, are being ORed together, which means that, yeah, this is executable too. Even if it says it's not executable in memory, it will be executable. So will this be executable, and so will this be executable. This will not be executable because this is on a different page. How do you know if something is on the same page or on a different page? You ignore the last 3 nibbles, the last 3 hexadecimal digit, and only look at the rest. So this is the page number 8048, and this is a page number 8049. So these are different pages, but here everything is the same page 8048. You do not count in pages, but you just ignore the last 12 bits to get the page number. yeah, and like if this is the same number, the same page, then the attributes will be like whatever is needed by all the sections which are located in that page. Sometimes you might even get like writable, but modern compilers try not to mix readable and writable sections together, not to place near them. Usually there's like some distance between them, but that happens from time to time. Cool. Okay, there are some questions which I'm looking at, but are not related to this task, so I'm going to keep going, and then we will go back to the questions which you have asked, which are like more general questions. The questions will not be forgotten, we will get to them eventually. Perfect. Now we have Droids 1, which is a reverse engineering challenge. Find the path, get the flag, cool. We can go to the shell here as well. APK. Okay, APK is, I was counting on some x86 assembly in all honesty. APK is Java. Yeah, we can play with it. Let's just play with APK. APK is Android. That's what I'm trying to, I guess that's why it's called Droids. So what we have to do is we have to download it. I downloaded it, then we have to, let's just go to that directory. Okay, and we have this file, and this file is an APK, and APK is actually a zip file, so we can just extract it, and we get a lot of stuff. Okay, now, I have no idea about Android, but that shouldn't be a problem here. Now, you have this lib directory. What's in the lib directory? In the lib directory, we have some libraries, which are both x86, ARM, or whatever. This is typical for Android stuff, and also for Mac OS. That you have some binary which is compiled into multiple different architectures. Sometimes it might be, you might be lucky that like one architecture does not have symbols, is a stripped binary, and another one has symbols. Let's see if there's anything even here. Okay, there's like, okay, and now OBS says it's been reconnected, so you should be able to see me again. So I'm guessing we will not even have to reverse engineer the Java here. Instead, we'll have to look at this lib hello something something, which is like x86 code. Let's just go to x86 32 bits because 32 bits are usually easier to analyze. Now, this file might not be related to the challenge at all. It might just be there for the rules, for like as a red herring. But I'm going to take a quick look at it anyway. So what do we have here? We have, like if the function has a really weird name and is prefixed by Java com something something, that usually means it's a function which can be called from the Java code, like function written in C or C++, which can be called from the Java application, like basically a native function. And there's like PicoCTF, flag stuff, and yeah. So let's just go to one of these functions. There is a lot of assembly stuff here, and I'm going to do this. Let's take a look at all these functions. Okay, that doesn't tell me anything. So I guess we'll have to look at the Java code. I'm going to keep IDA open because we'll go back probably to this function anyway. So let's go here, and we have this classes dex file. We have to convert it basically to a jar file, I believe. And to do that, there are some like dex to jar basically is the name of the application. I do need, however, a Windows console to do that. Give me a second because I need to resize the font. Okay, here we go. So, no, not here, here. Okay, perfect. So there's like a dex to jar file, well, script which you can download from the internet. And yeah, okay. Java, I do not have Java. How did that happen? Please bear with me a second. I need to find where do I have Java? JDK, oh, this Java will work. Okay. So I'm going to add set the path to whatever like this, and this is where I have Java. And now it should see Java, it sees Java 11, perfect. Okay, and now it's basically translating the classes dex into a jar file. A jar file, on the other hand, is this file. It's actually a zip file. So APK is a zip file, a jar file is a zip file. We can just unzip it. I'm going to make a new directory, I guess, where let's call it X, and I'm going to move this classes dex to X, and now I'm going to unzip it. There are quite a lot of stuff, most of it is related to Android, so we will not have to analyze it. Okay, here we go, and I believe we absolutely do not need to care about these two directories. We just go to the com directory. There's like a hello CMU. CMU is basically Carnegie Mellon University, is the university which, well, hosts the team PPP, which makes the PicoCTF. Okay, and there's some classes here. Now, we can use any decompiler. Java is actually a language which can be easily decompiled, so we can use any decompiler to decompile it. There's, for example, the compiler called JAD, which I absolutely do not have here. Do I have JAD here? I do have JAD somewhere. I do know I have JAD somewhere. Okay. Let's actually just go here to the X, com, hello, go, okay. And now I have this Debian JAD decompiler, Java decompiler, one of many. There are some online ones as well. And I'm going to tell it to decompile the class files. What's a class file? A class file is basically a compiled Java file. It's like an equivalent of PUIC file in Python, basically a serialized bytecode with some meta information. Okay, so it generated JAD files, and we now have some JAD files here. Not a lot of them, but that's fine. So we can open them and we can take a look. What exactly do we have here? I guess the flag stuff is the thing which we care most about. So let's take a look here. What do we have here? So we have if s equals context get string, get some string, I have no idea where the string is taken from. It then calls a native function which is called fenugreek. Fenugreek? Whatever is fenugreek. And if we look at IDA, we have this fenugreek thing here. So you can take a look here and see what's happening. Let's make it a little bit easier to read. Okay, and it also grabs the string like context get string. I have no idea what this is. Where does it actually get the string from? Does it get the string from some of the accompanying files? Like for example, there's this Android XML thingy. Does it take the string from here? I don't know. There's some resources file also. We'll probably have to figure it out at some point, not yet though. Probably if we could run it, if we could debug it, then it would be easier, but I do not have an Android environment. I might need to get an Android environment for debugging later on, if it starts to be a little more, like the challenges start to be harder. So yeah, I'm not going to care too much about this. Probably there are not a lot of strings around anyway, so whatever. I'm going to take a quick look on what are the other files which we got, like for example this huge R file. Okay, there are some interesting constants here which are pretty similar. Is this? What's a password? Oh, okay. Oh, that's easy then. It's basically, yeah, basically what's going on here is that there's a field somewhere in the application which is called password. And this get string from context, I'm guessing is just like gets the password from that field. Now, is this field, what does it do with this password thingy? It's not clear. It's a build config which I'm looking at. Nothing super interesting here. Main activity, which is probably Android stuff. I need to learn Android someday. Okay, so it grabs the... okay. So yeah, what's happening here is that this S, which is the string which is called to get flag as well, is being compared to this. And if that's the case, S is being called. What's S? What is the string? Where is get flag being called? This is the questions which I have right now. And let's do rgrep this get flag, which is showing me the files which contain the string. And main activity, there's okay, so main activity actually, which I did close a second ago, actually has this get flag somewhere here. So get flag S. What is S? S is the get. Okay, so I was mistaken. I was thinking that password is actually the thing which is the constant. No, sorry, the thing which is the input from the user, but that's not the case. S is the input from the user. Context is, however, not the input of the user. It's just some string. Now, a question for Android is like, what does it mean that a string is taken from a context? I have no idea, so I'm just going to Google it. What does this do? Context gets string. So one of the things on CTFs which you have to be good at is, like, you have this architecture which you have no idea about, and you still have to somehow be able to navigate around documentation, navigate about like around libraries and so on. And this is what I'm doing right now. I have no idea about Android. I did solve a couple of Android challenges in the past. I've never written an application for Android though. So yeah, and I played with ADB like once or twice, so that's about it. But yeah, like I can still reason about it just by reading the English name. Get strings probably will get a string, and it grabs a resource ID. So okay, so the string is probably going to be in a resource. And now the question would be, is this resource somehow related to this resource file, which we had here? Oh, there's a res directory. Let's go to the res directory. What do we have here? Quite a lot of weird stuff. Okay, what kind of stuff is this? XMLs. Yeah, this is probably not related. Doesn't look related. Yeah, this doesn't look related. As in, this looks like to be related to the libraries, not to the actual stuff. And there's also this file, which kind of bothers me. What is it? Not files, file. It's some data resource. Can we run strings on it? Strings on it. Okay, we can run strings on it. Can we grab it through Pico? There's a PicoCTF here. Perfect. Let's run it. Let's open it in a hex editor then. Pico. Okay. What's here? You know what? I'm going to do one more thing. I'm going to do strings -el. EL. Alright, not a lot. EL basically is Unicode 16-bit, and without it, it's just 8-bit. Let's take a look at the strings so we don't have to look at them in the hex editor. These are totally related to there's a password which is porcupine. Okay, so should we assume that porcupine is actually the answer to the password? I don't know. Maybe. Let me just copy this to some notes. What I'm doing right now is basically guessing, which is fine, like educated guessing still. I'm doing a recon phase where I'm looking around, trying to figure out what's going on. I do not want to... So okay, a proper way to parse this resource file is probably to get some how to say it, to get a dissector for it, or actually something which extracts it. And we can actually take a look if there's something like that online. Decompile APK online, that's pretty nice, but and does it actually play with resources? Oh, it actually does. It's interesting. Let's take a look how this works. I sometimes did use this, I believe, this website. Okay, give me 1 second. I'm going to select the file. Okay, I did select it. Let's upload it and see what's happening. If we can actually get to the resources, because we only use ad blocker. Please disable. No, I'm not disabling. I'm absolutely not disabling the ad blocker on Livestream. This might end with a YouTube ban if I would did. But because sometimes the ads are weird on such pages. So yeah, we cannot use it. Let's ignore it. The password might still be porcupine for all I care, or like this. So yeah, whatever. If we end up not being able to reason about it, then I'm going to go back to this file and try to do something more intelligent than just guessing. What's going on here? Okay, so we get... what do we know about how this function is being called? We know that it's being called like this, with a string. So the fenugreek is going to be called with a string. Probably there's some other stuff here which is not related to the arguments, more like Java context or something like that, like Java environment. And this is probably just getting the string from that. So I'm guessing that nutmeg, that this v7 here is actually the string. So let's take a look at that. But before we go there, what's going on later? Okay, so we know that we need to basically get an odd number here. So something which has bit, the first bit set to 1. Or make it like a 0th bit, whatever. And if it happens, then we are going to anise. What's anise? Anise is calling the anise. And it's going to do an unscramble on something like this, where it actually uses, yeah. So, okay, whatever we provide is being used as a password, which is cool. So we go to this unscramble, and let's look here. So this is, we already know this is some kind of an encoded string, probably a password. Oops, that's not what I wanted to do. Let's go back here. So this is the unscramble. And what is that unscramble doing? The unscramble is doing something like this, which is perfect. Now, what is going on here? I absolutely do not care. You know why? Because I am lazy. And because I am lazy, I'm going to create a new C++ program, and I'm just going to copy paste it. So I'm going to copy this. CTFs aren't about being always doing it correctly. CTFs are about getting the flag. So I'm not going to analyze this code. This is probably some XOR anyway. I'm not going to even care about this. What I'm going to care about is this number. Is this something weird here? No. There is what I need to do here to make it run. I need to grab this though for later. Okay, let's get some headers. String maybe. And I also need std_int.h so I can do define, what's it called? Type def uint8t to byte. Okay, so now we defined byte as this, so we have this byte type now defined. Size t is from studio, or like standard input output. Sign in is fine, this is fine. Calloc is from either of these libraries, like depending on the compiler actually. Cool. Then we have unscramble being called, and we call it from, we don't care about this. This is just the calling convention. We do not absolutely care about the calling convention. Let's define main. Okay, and now we need this buffer. And to get this buffer, I'm just going to go here. Go to this buffer. Okay, here we go. Now, how do we get this buffer? I'm just going to copy it. I'm not going to copy the rest of it, just this buffer. And I'm going to put it here. How is it called again? Yeah. Cool, and it's going to be an array of bytes for me. Now this obviously, like, just copy pasting is not going to work. What I need to do here is I need to remove this. Now I need to remove this and remove this. Okay, so let's do this, and yeah, perfect. And now I'm going to do this, go here. Yeah, that's absolutely not what I wanted to do. There's one more thing which I'm going to add. I'm going to add the H letter. No, I'm just going to do it a different way. Whatever. Okay. Select this, remove this, add a comma at the end, do this, now do this, okay. Remove the last comma. I'm basically reformatting it so it's actually C syntax compliant. Now there's this H here, which does not work. Actually, I did it incorrectly. What I need to do at this step, I need to write OX here. Yeah, that's better. Okay, now I need to remove the H, and to do that, I'm going to do find me H, and then in the selected, where's the selected? In the selected part, and replace it with nothing. Perfect. Okay, cool. And now I can do this. Cool. So we have encrypted string. We kind of know the password. We just need to call it. Now, which one is the password here? Oh, we need to look again at the function which was called. Which function was it? It was Anis, right? Yeah, it's okay, so I'm actually going to copy this as well. Both of these are like, no, this is a char pointer and this is a size t. It can be an int, that doesn't matter. And as is our password. So I said that our password is probably going to be this word. Because why do I think it's this word? Because it's next to the password. So I'm just going to copy it. It might not work. That's fine. And here, what do we get returned? We get this buffer being returned here, which is fine. So I'm going to do puts with this and see and compile it and see if it works. Where are we here? Perfect. G++ is the FCC. This is blah blah blah. It wants a const here. That's fine with me. Then it says that we're on invalid type. Why is it an invalid type? Oh, because this is an int, but there's some weird stuff here going on, and this is because this is on me, because I did here. Sorry, I should do this. Yeah, and now let's copy it again. Actually, let's copy just this loop, because if I press backspace, not backspace, backslash, it removes the casts here, and these casts need to be here for this to be a valid code. So it's the reset, because I cannot see the top of the errors, and when debugging you do not care about the bottom error, you always care only about the top error. Invalid conversion from void pointer because this isn't C. So that's the difference. In C this would work, in C++ it doesn't work, and I didn't name the file CC, so I do have to do this. Okay. Okay, blah blah blah, error invalid conversion from, why is it okay, to integer to unscramble here? Because it should be let's just do a void pointer here. Now let's do a byte pointer here. Okay. Okay, when it casts a pointer, blah blah blah, different sizes, let's do -m32 to compile 32-bit code. And when it's it cannot convert this because of this. From char to int. Why is it an int? A3. What are you doing, A3? It's not an int, it's a char pointer. Okay, invalid conversion from byte to constant char. This is on the puts, this is here. And we want just a char pointer, doesn't matter. Okay, cool, it compiled, it still might crash. Does this look like our flag? No. Okay, but as I said, there are some other strings which we want to which we can actually check, right? So let's do let's actually trim it. Wow, this is crazy. Okay, how many spaces are here? All of them, perfect. Okay, why is this? Wow. Okay. Okay, perfect. Now we have a list of words which we can use. I don't know which one is it, doesn't matter. So what do we have here? We have a const char list of words. Okay. And now for let's just do a null here. Let's do it a different way. Okay. Sorry. This is what I want to do. Okay. Yeah, this code isn't beautiful. Whatever, doesn't matter. Does any of these look like a flag? No, not really. It has the right length, it doesn't look like a flag though. Which is fine. So what do we do now? I guess we are back to trying to figure out what's the format of that resource file and to unpack it. Which is fine. Yeah, so it's basically look for a tool which unpacks like resource APK, the compiler, any lib to extract. This is what I'm looking for. How do you place the cursor in multiple places in the file? In Sublime, you have to hold Control. Like you hold Control and then you can put the cursor in a couple of places. Another thing is you can select everything and then Control-Shift-L and you get a cursor per each line. This is actually super useful. I really like it. We don't want a library. Want an extractor. Okay. If you know any tool, just hint me on what should I use. Okay, another thing which you can do is actually let's run strings again on this resources file. Strings, obviously. It's quite a lot of them. See if we missed anything, because I think on the chat you're actually saying that. Oh, you're saying that in the strings XML file I should have strings XML. So let's look for it. I do not believe I have a file like that. What XML files do I have? There's like layout stuff. Andrew, no, doesn't seem I have like a file like that. So yeah, let's do this again. Oh, there's some other stuff here. Brute force not required. Okay, that's fine. Well, in this case, I'm just going to copy some more animals here. Yeah, there's quite a lot of strings which I could probably use here, which isn't the greatest. Yeah, we seriously need to just do it properly. Source file and extract the useful and actionable content for it. And do I seriously have to compile it with Bazel? I don't even have a Bazel installed. apt. Okay, sources. Can dump resources, that's nice. Alright. So, you know what? I'm actually going to still do it a CTF way instead of doing it properly. So I'm going to dump all the strings to asdf.txt. And now what I'm going to do is I'm going to create a Python script called asdf.py, which does open with open asdf.txt, read binary, oh, not binary actually. Oh, actually read binary. And I need to run it in Python too. As f read split lines, and I want to put it in lines. Now for ln in lines, I want to do strip it, like remove all spaces from both sides, and then I want to print it in a proper form, which actually requires a list. ln just add it, but I want to add it with quotes at the end and at the beginning. And then I want to print it as join it with a comma. Okay. So this is why you use Python, because it's like super fast to write such code. Perfect. And now we are going to brute force it. Well, brute force it. And let's call it, I don't know, like words.h, perfect. And now I'm going to do something nasty, which you do not really ever do. I'm going to do include inside of a function, inside of a table, words.h. Yeah. Don't do it at home, kids. What did you... Oh, I need to escape it. How did you escape it in Python? Okay, and code C string? C string, like string. C escape. Escape? How did you encode stuff like that in Python? Python string escape C. Not character C. Encode. No. No. there is a way to do it in Python. It's not Unicode row, codex, what's it? String escape, this is it. Yeah, this is what we have to do. Did it do a string escape? Didn't do string escape the way I wanted to do. Well, okay, I guess we're going to have to use this one. This is a nice function. Thank you, whoever posted it. Okay. This is odd. Okay, this looks fine. X, okay, perfect. Cool. Okay, let's try to... Okay, now it works. And I'm going to grab -i pico, and perfect, here we go. So this is the way we should do it. A lazy way without actually looking for a proper extractor. Pinning for the fjords. Okay, that's perfect. Cool. So yeah, this is like, this was a perfect example of how to not solve an Android challenge, and how to solve a challenge on an architecture which you do not have really a clue about. As in, well, you wing it, basically. In this case, we just extracted all the strings from the file. We used a Python script to, well, to output all the words in this format. Yeah, so we got all the strings. It doesn't matter if the strings make sense or not. We just took all of them. Then we put it into a code which was basically copy-pasted from IDA, from the disassembler, or actually the compiler in this case. And we took the string, we called it, and we grabbed it for the flag. And guess what? We got the flag. So congratulations to us. This is absolutely not the way we should have done it. So, okay, you say on the chat that there probably is a values. No, I do not have this. I do not have value strings. I did look for strings XML, but it was not there. So yeah, this is the end of this challenge. Did we claim the flag? We did claim the flag. So you can go and do the next one. Are there any questions to this challenge? I do hope not, because again, I do not know Android. So this is the way I would solve the challenge though. And thankfully we didn't have to look at the assembler code too much either. Like what the compiler showed us was enough. So I'm also happy about that. Let's see at the questions. What's the difference between got.plt and plt.got? Let's open that previous challenge again in IDA to take a look. So in plt.got, which is here, we have, I have no idea what I'm looking at actually. Good question. This does not ring a bell. So the got.plt is this is where the pointers are in got.plt, and plt itself are the functions which are called, which are supposed to resolve the pointer and then put it there. And what's inside plt.got? I don't know. I probably should know. For some reason, I do not. So yeah, you can just say that. Yeah, I have no idea because I don't. Cool. There is a general question. I will do all the general questions after the next challenge. So that's in like 20-30 minutes. So sorry, I'm not ignoring you. All the questions which are general questions are in my question list. I will get to them later. if you have any general questions, you need to ping Foxtrot Charlie, by the way, so he can put it on my question list. Remember about that. Okay, I see you like on the chat the way I solve challenges which I have no idea how to solve. That's fine. Again, CTFs are about being adaptable, right? It's not about knowing everything. It's about learning as you go. So we can close this, and then we have binary exploitation again. Cool. Let's do binary exploitation. Exploit the function pointers in this program. The program can also be found here, and we again have the source code, which is really nice. This is on a real CTF, you would not have a source code. And we cannot cut the flag, because we do not have permissions, but if we exploit this vuln here, it will have permissions to grab it. Let's take a look at the source. I do need to download this though. And what's the name? Pointy. Pointy like a pointer probably, again. Sorry. Here we go, the source code. Okay, oh, that's a lot of code. 100 lines, that's not what you expect on PicoCTF. Okay, what do we have here? Let's see what happened. Okay, what do we have here? We have a global variable of addresses. Sorry, a global table of addresses. One more thing I'm going to check before we get there. File vuln. What is it? It's a 32-bit binary. And then let's do checksec on it. Checksec.sh is like a super great script for checking the basic protections of a binary, like basic mitigations inside a binary, basically. We do not have any address space layout randomization. That means every address we see in the binary will be the same address in memory, which is great. Then we have a canary, which is not so great for local buffer overflows, but we might not play with the stack at all, which is fine. And then an X, which means we cannot execute code from non-executable pages. Because then like it would just crash. Cool, we have a win function which just grabs the flag from this file and outputs it. Then we have a structure like, this is a structure which is the name of a given size. The size is 128 of a professor and the last score. And then we have a student, which has also a name, and then it has, this is going to be a use after 3. Let's see. And then it has a function pointer. This is a function pointer, so it can be set to any function which has this prototype, which doesn't return anything, and it takes 2 things as input, which is a pointer to the professor structure and an integer. Okay, then we have give score to professor, which takes the professor and it scores the professor. I guess, yeah, it puts into this last score the score, and it writes like given score, which is fine. Then there's a retrieve professor, sorry. Is this addresses, just addresses? I was thinking, is this like professors? Is it students? No, just addresses, which is really weird. This is going to be type confusion. Like, this is my bet. This is going to be a type confusion vulnerability. But let's see. Okay, so I'm going to tell you what I think is going to be in the challenge, okay? And then we'll see in the code if it's actually there. This table is going to be used both for students and for professors. And it will not note which type is under what index. It will just like tell you that, okay, you create a professor and it's being put in index 0, and then you can use it as a student, like call functions which operate on students, but you give it an index where a professor is residing, or the other way around. So actually, if you put into the last score a pointer, an address, a valid address in memory, and then you call student, and then you call some method and tell it like this entry is actually a student, it will try to execute the last score as a function. So whatever address you place here, this will be called like a function. The address will be jumped to. Rather the address will tell where the CPU should jump, where the function is located. And this is called the type confusion attack because we confuse two types. We confuse the type professor and we confuse the type student, and they should not be confused because, yeah, like in memory, there is the name, and after the name there is the last score, and here the name, and after it is the function pointer. So this is what I will think it will be about. But the exploit will be to create a professor, in the last score put a function pointer to the win function, to this function which is here, and then call some method which for whatever reason calls the score professor function on the index of the professor. And so instead of this, like a proper function pointer, this will be used as a function pointer and the win method will be called. And this is my prediction. Now let's actually look in the code. Okay, retrieve professor. We what do we do? I'm out of water. How did that happen? I have some water here, thankfully. Okay, so it's a loop from addresses taken. What's an addresses taken? What is this? Oh, it's just an integer. Okay. It checks if it assumes that it's a student, and it checks if the name of the student. Okay, so this is actually abusing the fact that both professor and the student have the name in the same location. Now, this looks weird, but it isn't as common as you think. It's actually a pattern in C which you use, but usually you use this pattern with union, and you do it like this. You'd like declare this, and then you do union, like common, whatever you want to call it, and you do this, and then you do struct professor and struct student. Yeah, this is how usually the pattern looks like, and here it would be a cast to, where is it, to common. And only after determining, and this would actually be, it wouldn't be a name, it would be a type, and then it would be a cast to a given type. And the pattern relies on the fact that the first field is always the same. Now, is this a legal pattern? I think we would have to ask the standard lawyers to tell me if it is legal, but you can find it in some libraries that is being used in some C libraries. For example, libsdl is one of the libraries which uses this pattern. Cool. So yeah, but they do not have a common, so they have to use some structure. And they absolutely like already mix the types, right? Retrieve professor, but they cast it to a student, and then if it finds a given name, then it returns the given address. And otherwise it says person not found, and bye-bye. If it says retrieve student, the same stuff. If it say, oh, that's just a read line, whatever. Anything funny here? No. That's weird. This is like super low level interface. You usually don't use read because it's super low level. It's like a syscall, basically, a system call to the kernel. What you use is you use fread or like fgets or whatever. But yeah, whatever. It's fine. It's not bad. What is this? Okay, and then we have input the name of a student, and we allocate a student. And then we put it to address taken. This address taken is okay, that's fine. And then input the name of the favorite professor, and we put the name of the professor. And there's this give score method which is being put at, yeah, basically like this is going, the address of this function is put in this function pointer for the given student. And then input the name of the student that will give the score. And the student is, we read the name of the student, we retrieve the student, and we input the name of a professor that will be scored, and we retrieve the professor, and then we input the score, and then we call the from the student, we take the function pointer, we resolve it, we reference the function pointer by calling the function. This is enough. You do not need any asterisk for function pointers. This is enough to just call it. And we call the professor and variable. Okay, but that's pretty simple. So what do we have to do here? We have to create a professor. Yeah, we have to create a professor which has the score. Let me think, because we will have to do it in 2 steps. I need a notepad. How do you say student? Student? Student is the Polish pronunciation. I always thought English was student, but feel free to just correct me, because I always was wondering what's the proper pronunciation of student, student. Student? Student! Oh, it's student. Obviously it is student. I even knew that. Okay, student it is. Too many languages. Cool. Okay, so what do we need to achieve? We need to achieve a professor, having a professor which has the last score set to win. We need the address of win. What's the address? And then we need to basically be like the professor needs to be confused and the last score needs to be called. So what we actually have to do is we have to, in the student here, the student will have to be confused here. Perfect. What we need is we need the address of the win function. This is the important thing right now. How many not programming languages do I know? I know English, I know Polish, I learn German, I've learned in the past some Japanese, that's about it actually. I know some words from other languages, but that's about it. Okay, what I'm looking for is win, this function. I do not care about the assembler right now, I care only about the address. This is the address. Okay, so this is the address. Now I need to actually convert this address into decimal again, so I'm going to just use Python for it. Here we go. So yeah, just do this. Perfect. Now, where is my code? Okay, input the name of a student. And then we do the professor, we allocate the professor, and then we... Or are we doing it the other way? We are... give score. Because we can do it the other way, we can just override the student's function pointer. Yeah, I think we can do it like that. So let's just do it like this. Okay. Name of a student is going to be S, because we are lazy. Then name of a professor is going to be P, because we are lazy. Then, by the way, the score is not set to anything, it's uninitialized here. That's another bug, but not the one we are... Well, we cannot exploit it anyway. Then we get the name and we retrieve the student, and okay, and so the name which of the student of the professor which we are going to grade is going to be actually S, because we are going to override the student. Yeah, this is the like 2 ways we can go about it. We can this is one way, which I explained before. The other way, what we can do is we can basically do the type confusion the other way. Basically, instead of supplying the name of a professor, we supply the name of a student. And that way we this call will set this call will set the function pointer, and then we just do everything again, and that will be it. Cool. So we select the student as the professor, input that will give the score. This is fine. And then we select the student as the professor. So again, the S as the student. And then we give the address of the win function, which will be written into the function pointer of the student. And then we go again, right? So what we do again is we just enter bogus information because we do not care about creating a new student or a new professor. We care about grading again. So which student will give the score? S, because we just overwritten the function pointer here. And then doesn't matter which professor, absolutely doesn't matter, or does it? No, it doesn't, because win doesn't take any arguments. So it doesn't matter here, whatever we say, let's just say A. And then input the value we are going to give 4, because it doesn't matter for T2, it doesn't matter what we put here. And then the function pointer, which we overwritten in the previous round with this value, is going to be called. So this value is going to be put into the register, like the CPU instruction pointer register, which will point to the win function. And I think that's the idea. So let's try it. I'm just going to copy paste it. I'm going to assume that it will work. But okay, are we in the shell? We are on the shell. Let's call vuln. Let's put it here so we can see it. So okay, name of a student. Name of a student. Sorry, thank you for correcting me there. S, name of a professor. P, of the student that will give the score S, and the professor. And here this is the type confusion moment. S, we give the student instead of a professor, and the score, and we give the score. What happened there? I don't know what happened. Let's do it again. I think I did pressed something wrong. So that's my mistake. I'm sorry. I apologize for that. Let's do it again. SPS type confusion at this moment. Enter the score. Okay, now it's fine. And now the new student, the new professor, the one which will give the score is the one which we have overwritten the function pointer. So this is S. Doesn't matter what we put here as long as it exists, A exists. And now the score 42 doesn't matter what we put here. And win was called, we get the flag, and everyone is happy. Yeah, so this is a typical type confusion bug. This is not common on CTFs. You sometimes get it, but it's super hard to make a cool type confusion. Usually you get a use after 3 into type confusion, but yeah, sometimes you get it. It's a great challenge to learn it. I really like this challenge because of how easily it showcases the type confusion. So it's a nice challenge. You should try to solve it on your own. And yeah, we got the flag. So there we go. Perfect. Let's do okay. I'm actually, this is interesting, the next one. But let's do it next time. Okay. Enough for today. Let's do the questions. And after the questions, we can call it a day. And then next week we will continue because we still have a lot of challenges to solve, folks. Perfect. You will, if you have any questions, you have to write to Foxtrot Charlie. Actually, I should have worn my PicoCTF t-shirt for the stream. Whatever. I have an init G1, which is like a Google event for students about security, which takes the same place as Google CTF Finals. Well, did last year. Okay. Ridanus Supervoid asks, what do you think about implementing DBI via ptrace in terms of speed, portability, of course? DBI is the dynamic binary instrumentation. It's basically when you want to, you have some binary, some program, and you want to run your code in between some other code. So for example, you want to hijack a function which is called, or you want to squeeze some code in between, like run at the beginning of the function, at the end of the function. You use this mostly for understanding how it works, how the application works, and putting debugging output code into the application. This is usually why you use DBI. Sometimes it has more advanced usages as well, but I guess this is the most the simple one. Anyway, so what do I think about ptrace? Ptrace is the debugging interface on Linux. I do believe we had live streams about creating debuggers both on Windows and on Linux, like super simple debugging loop. So in terms of speed, it's slow. Why is it slow? Because each time you set a breakpoint with ptrace, you have to, like, the breakpoint hits and then it goes to the kernel, and now the kernel schedules the debugger process to be woken up, and then something happens and the debugger process, the DBI process, is being woken up, and it uses the ptrace interface to like get some register values, get some memory values, and so on. And then after doing that, it hands off the execution back to the binary, which we are instrumenting, which actually means calling the kernel again, and the kernel will wake up that binary. Sorry. Now, this is slow because there's a lot of kernel calls going on, but it's the easiest way to do it, the easiest way to do DBI. There are other ideas how to do instrumentation. For example, you just inject code into the application. This is a little bit more annoying because you either have to do it manually, as in manually figure out how to make the beginning of a function jump to your code, preserve all the arguments, preserve all the environment, do something, restore the environment, and then jump back. And that beginning of a function, you have to override it with like some jumps, and there might be some instructions which you have to emulate in your code at the end before jumping back. So this is a little bit annoying, but this is, after you do it, after you rewrite the parts of a program, that works pretty well. It doesn't work, of course, if the binary has like some control flow integrity checks or some, well, that might even work. But if you start playing with binaries which have checksumming of functions, then yeah, you have to disable the checksums. So that's pretty normal. Anyway, so that's one thing, one way to do it, and it's usually how there are DBI engines which do that for you. So you just point to a function and they do everything and like allow you to squeeze some code in, which is pretty amazing. Now, I think that's how Frida actually works. Frida is pretty high level though. Yeah, Frida is amazing. Like, that's a great tool. Now, another idea is to, for even more advanced engines like DynamoRio, is to virtualize part of a code. And by virtualize, I mean rewrite. It's complicated. Read the papers. Read the white paper, basically. But it's pretty amazing what they do. It is pretty advanced as well stuff. So yeah, like these are the approaches. The ptrace one is the easiest one to implement. It's the slowest one as well. So there you have it. Okay, Humphreys Pinto, I'm sorry if I butchered your name. Do you know of a tool to walk through thousands of crashes generated by AFL to determine its exploitability? On Windows, WinDBG, or like WinDbug, or Windows Debug, or whatever you want to call it, has something like this. Like, it has like exploitability thing, which you can use for exactly that purpose. Now, on Linux, it's a good question. Okay, so I did hear about such tools. Now, the question is how many of these tools are public, and I do not know the answer to that question. You'd have to actually look. And at the end of the day, do note that you will not get a yes/no answer. You will get probably a probability. Now, this is actually also not too hard to code. There are only a couple of types of crashes which are easy to exploit, and there are other types of crashes which are usually non-exploitable apart from DOS scenario, like denial of service scenario. Like these crashes which are easy to, or like, let's start with the crashes which are obvious non-candidates, and that would be like division by zero. Usually, there might be cases where a division by zero happened because of some memory corruption, which is exploitable, but usually it's the last thing you look at. So yeah, like that's SIG FPE or no SIG FPU on Linux, I believe. So that stuff is you do not care about. Then usually reads from weird addresses. Read from zero is almost never exploitable. Write to zero is almost never exploitable. What you are looking for are writes to an arbitrary address, which is a non-zero address, not an address which is at in the first page of memory. That's the things which are the most likely to be easily exploitable. But you are dealing with probabilities, because at the end of the day, you do have to look at the code to figure out what, like, is this exploitable or is it not? Because even if you have a nice write condition, like write crash, which writes to some memory address, which you can even partially control, it doesn't mean it's exploitable. So yeah, like you can say that something is exploitable the moment you have an exploit working. Basically, before that, you are like dealing with probabilities. And even if something is not probable to be exploited, like the division by zero, there might be weird cases in the application, and some cases where it's actually exploitable to code execution. Does not happen likely. You are dealing with a low probability. It's not a zero probability. It's super low, not zero. So yeah, be careful when using such tools, but try to write a tool like that yourself. It's not hard. Another tool which you need is for deduplication of crashes, because you might have like 5,000 crashes, but all of them caused by one bug. So you want to also think about how to write a tool which does deduplication of crashes. Usually it's pretty easy to have GDB scripted with some Python or some GDB script to output proper stuff, and then that being parsed with Python and has some logic to try to like just triage basically the crashes, like sort the crashes which are most probable to be exploitable to the least probable. The more experience you have with exploiting, the easier for you it is to set the heuristics correctly. So if you didn't do any exploiting before, then you might get better with actually using some ready-to-go tools. Just remember you're dealing with probabilities here. But that's an excellent question, by the way. This is a really good question. Okay, but he writes, general question, can you tell us about the challenges you will work on for the next episode so we can try them by ourselves? Okay, yeah, sure, that's an excellent suggestion. Where is my browser? We are going to go for Seed Spring, then Voltador 6, and maybe Afterlife. This still sounds like a use after 3 Afterlife. And maybe Empire 1, depending on the time. So yeah, these are the 4 challenges which I will look at next time. Really good suggestion. Okay, that one I did already answer. Eridano Supervoid writes, any stream about taint analysis in the future? Do you use this technique in your security research? So I didn't use it. Taint analysis is useful in some cases, but it's like this. It's tricky to implement on low-level languages, and it's but it's useful for like some types of vulnerabilities to trace them. We might play with taint analysis someday. It's not a bad idea for research, but it's Yeah, I will have to basically look what kind of taint analysis tools are available, because it's like this. I know how to write a tool like that, but writing a tool like that takes weeks to basically get it right. So yeah, but taint analysis is a really nice technique. We should make a stream about it one way or the other, but yeah, I would love to have it more practical than just the theory behind it. Are technical writing skills required in security? For a question from Joel. Good question. I wouldn't say that they are required, but they come in handy in a couple of cases. They come in handy when publishing research. That's the obvious one, right? You do not have to publish research when you work in security, because not every security person is a security researcher at the same time. I would say most of people are not security researchers, and that's fine. Like, yeah, there's like a lot to do anyway in security without trying to like research new stuff, and sometimes researching new stuff is painful anyway. Then if you are in pen testing, writing reports, that's technical writing, and you have to write it well to be able to explain the problems to the client. Sometimes the pentester teams have actually a person who is responsible for that, and not everyone in the team has to do it, which is a good thing or a bad thing, however you want to look at it. When reporting bugs in like vulnerabilities and bug bounties to like vendors, maintainers, and so on, it's also useful to know how to properly explain it and how to approach it diplomatically, because otherwise, yeah, like if you're writing an email, I guess, to reporting a vulnerability to a company which has no idea about security and how to properly handle security reports, they will just lawyer up if you don't explain it properly. So that's not fully technical writing, and it's more like diplomacy, I would say, but it's like somewhere in the middle. I think that's it. So it's not a crucial skill, but it helps. But again, not a crucial skill, it helps. That's what I can tell you. What's the difference between symbolic execution and concolic execution? This is what I always confuse. So please check on Wikipedia, because I always confuse them anyway, so I would explain you incorrectly. So just check it on Wiki. There will be a day when I will stop confusing them. Alal writes, hey, how would you go about implementing concealment via EIT hooking in ring-free rootkit? Any alternatives to injecting a DLL to all processes? Okay, concealment via import address table hooking in ring-free rootkit. Any alternative to injecting a DLL to all processes? Well, if you're going for IIT hooking, not really, because you have to get all the processes. If you would use a different technique, then it's a different thing, right? But if you're using IIT hooking, then yeah, that's it actually. You do have to get all processes. There is like no way around it. And I don't think there are like any other. So ring free is pretty, I would say, is pretty restricted in what you can do. And in the end, in ring free, you have to get all the processes, because otherwise a process can stumble on your file, and which you might not want to. Instead of IIT hooking, you can like override the function in the DLL itself, but yeah. And as for alternative to injecting a DLL to all processes, well, you don't have to inject a DLL, right? This is the easiest way to do. You inject DLLs because it's like three line code which injects a DLL. You do not have to inject a full DLL. You can just inject your code. This is a little more stealthy than, depending on how you approach it. It might be a little more stealthy. It might be less stealthy. But yeah, so you don't need a full DLL to do that. You just need to inject your code. So like allocate some memory, like change the privileges of some memory to be executable and put your code there, then do some like EIT hook into your code, and that's about it. So yeah, that's all I can say. Like, yeah, this is like a pretty high level, low level question, and yeah, rootkits are fun. Wrench Pandya writes, what is your suggestion on Windows Internal 7 edition? There's already a 7th edition? I need to buy it then. Do I have a 7th edition? I think I have. I don't. I don't know. My suggestion about all Windows Internals books is like to have them on the bookshelf and read them. Yeah. I do not get any money from them for saying that. It's just like a magnificent book. Okay, are there any other questions? Start learning by coding or start learning how the things work by experience? By coding, I would say. In a lot of areas of IT related to hacking, I would say like knowing how to code is really needed. You need to know how to code. You need to, and when learning to code, you basically get a better understanding of the operating system, of how the APIs and so on work, what is it about, and like how programs are structured. I heard OpenCL is being deprecated on macOS. What does that mean for tools like Hashcat and John the Ripper? Good question from Albert. I have absolutely no idea because I'm not a Mac user, so I don't know. I mean, if OpenCL is being deprecated, it's still not the end of the world because you can still like do computations on the GPU just using different ways. So I guess for Hashcat and John the Ripper, that might mean that they will not be able to use OpenCL, but they might be able to use some other types of running stuff on GPU. Especially that like there are compilers right now which just like grab a C code or C++ code and compile it into a GPU compute shader, and you just like hook proper stuff, and but that might not be a lot of work to make it to like take whatever they currently have in Hashcat and like just run it on a compute shader, compile it and run it on a compute shader. What do you think? What do you think about in-memory fuzzing? How does in-memory fuzzing differ from in-process fuzzing? That's my first question. Is there a difference? In-memory fuzzing. What's in-memory fuzzing? It's a technique that allows the analyst to bypass parsers. Oh, this is what they call in-memory fuzzing. Okay. So it's like this. It's not the way I usually would go about it. I would go about it in a little different way, as in actually my usual way would be to rip a part of the application to run as a standalone and fuzz that. Now, in-memory fuzzing is like run the application to some point and then change data in memory and run like the thing which you only want to fuzz, which is kind of the same thing with the two different approaches. Now, should you not use in memory fuzzing? Should you always use in process fuzzing, or like the idea to rip it out? Doesn't matter. At the end of the day, is like whatever way you reach the code which you want to fuzz, it's fine. And at the end of the day, you want to fuzz the smallest piece of code which you get, which you are able to. It's not always true. Like, for example, if you're fuzzing FFmpgs at the beginning, like which is like a large codec library, at the beginning you want to fuzz everything. And only then, after you are looking at the at the map of what is most heavily fuzzed and which codecs are only like on the surface, are a little bit skimmed on the surface, and that's it, and never any code doesn't reach anything deeper, then you want to probably take that codec, analyze it, see what's the problem, why does the fuzzer cannot reach anything below that, and then fuzz that thing. Do you want to rip it apart? Maybe. Do you want to just leave it there, analyze it, and fix your fuzzers to create some kind of binary to always reach there? Maybe. Do you want to do in-process fuzzing to force it to always reach, go there? Whatever works. It's just a technique, I would say it like that. If it makes sense for a given target to do in-memory fuzzing, then just do that. If it makes sense to just rip out the piece you want to fuzz and like detach it, decouple it from the network code, then just do that. Yeah. Ziad Hassan writes, can a fresh graduate work in pentesting without having a CVE or finding vulns is a must? Pentesting isn't about CVEs, actually. So CVEs is what you get if you are a vulnerability researcher, if you are a bug hunter, basically in software, in applications, not in services. Pentesting is more about testing, testing services, and you do not get a lot of CVEs in pentesting. You get way more CVEs in doing vulnerability research for publicly available stuff, assuming you are reporting that stuff, right? So you do not need CVEs. That's what I'm trying to say. There are a lot of like super smart security people who do not have any CVEs because, first of all, that's not having CVEs is a byproduct. It's not a requirement. Okay, it's like if you are a security researcher and you work on a certain type of applications and you report your bug upstream, you will get CVEs. Otherwise, you will not, and that's a side product. So for pentesting, you do not need CVEs. Absolutely. There are really like, I can probably think about 5 or 6 different teams and companies in the world which might actually require CVEs and have a good reason to require the CVE. If a company requires CVE for something like, I don't know, you are doing log analysis and log scanning and they require you to have CVEs, then they have no idea what they are talking about. And like, don't focus too much on CVEs, seriously. It's a byproduct. How do you fuzz kernel assuming you don't have access to the source code? Well, usually the same way you fuzz anything ever, just that you want to run it on some kind of a virtual machine or some kind of an emulator. But like, you fuzz the kernel as you fuzz any other type of code. You enumerate all the inputs and then you write some code which reaches that input and provides the fuzzing data. In kernel, that is usually 2 things. The first thing is system calls, and there are like system call fuzzers for Linux, take a look. And then there are the device drivers, which have like a devices which you can read, write, and IOCTL to, and this is your second typical vector. There might be other vectors as well, like for example network vector, right? But that's kind of from the outside. Well, kinda, or kinda you can reach it through a syscall, but yeah, so these are like the 2 main, I would say. Well, you can argue that you can reach devices from the syscalls as well. You can reach everything from the syscall. Well, most of it, whatever. But yeah, same stuff as an application, just run it in an emulator or like virtual machine. It might be a little bit harder if you need to do stuff, if you want to do stuff like super smart buffer overflow detection, and this is where things get tricky because you might need to do some binary rewriting, which is going to be a pain and you are going to spend a month on it, but it will give you good results. Emulators can be used for user-land binary fuzzing as well. Yeah, like AFL and QEMU mode uses that. So yeah, absolutely. Okay. I'm trying to get into Linux kernel exploitation 101, but I'm finding it very frustrating to set up a decent debug reverse engineering environment. Yes, that is absolutely true. It will hurt. You will have to put a lot of effort in having a good environment. There is no way around it. Do it. Like, you have to get through this and try to get all the different approaches that people have on the internets to do it, because they're different, really different approaches how to do it. Like someone might say, yeah, like use a virtual machine with I don't know, like VirtualBox with Windows on it with virtual KD and WinDBG. Another person might say that, hey, use actually another machine which you buy for like $50 and set up Windows there, and then use like USB 2 with a debugger cable to do that, or like FireWire or like Ethernet or whatever to do the debugging session, and someone else might say something else. So there are different ways to do it. You do spend the time, do invest the time. The better environment you have, the more bugs you will find at the end, because the less painful it will be for you to do it. But it is a pain to set it up. I understand that. I know that. There is no way around it. Yeah. Do I know any good resources for it? So depending on the operating system, actually, you can ask on Twitter. You can take a look on the honorary bot live streams on my channel about setting up, about Windows debugger. Basically, he describes his environment, which is pretty cool. But I do not have any great resources. There are books for like WinDBG, which kind of talk about it a little bit. You might find also in Windows internals, but yeah, at the end of the day, I do not have any great resource for it. But doesn't mean it doesn't exist, I just don't know it. Okay, baby step for fuzzing or starting a career in vulnerability research. I'm glad you're asking, because this is a way for me to show off my blog. So we go here and to the English side of my blog, and we look for FAQ, and not this one. This is how to learn reverse engineering, how to find vulnerabilities. So take a look here, and there are basically 3 ways to find vulnerabilities. Just read through it, maybe something will come to your mind. But do not start with fuzzing. Like, I know that a lot of people are jumping to a fuzzer and then they are looking for vulnerabilities that way, but they are missing the basic education to do proper fuzzing, and they might not find a lot of vulnerabilities, and if they find a vulnerability, they will not have a good idea what to do with it, how to analyze it. So I would actually start manually, and after you understand what you're looking for, how to exploit it, then use a fuzzer. But that's how I would go about it, or at least do it in parallel, because you need a lot of background knowledge to use a fuzzer properly. Fuzzers are super simple tools, but you need the background to know how to use them properly. Otherwise, you just skim the surface of a target and you'll not find anything, or you'll find stuff and then again don't know what to do with it. Yeah, anyway, that's the blog post which I would advise reading, I guess. And do know the types of vulnerabilities and how they look in code. But yeah, that's everything is in the blog post. Userland has a bottleneck of syscalls. Is there a reason to fuzz everything inside emulator which can be accessed via DMA or something? No, I mean, if you can, as I mentioned, if you have a separate machine where you want to fuzz it, then yeah, sure, just go for it. There's like, there are also different ways to go about it. You can, if you are like, want to put the engineering work into it, you can basically take whole parts of the kernel and move them to userland. There is like even a Linux kernel userland project, right? And run them in userland with a fuzzer. And that might be quite fast as well. Yeah, okay, let's finish it here, folks. Thank you to Foxtrot Charlie for being my moderator today. Thank you to everyone here. There were actually over 200 people today, so hi, thank you for being here. And see you next week and tomorrow if you speak Polish. If you speak Polish, we are going to do some simple honeypots. Let's see where that leads us. And next week on English stream, we are going to continue with PicoCTF. Hopefully a couple of more streams and we'll be done with it. But well, on the other hand, like, yeah, it's like if we go 3-4 challenges a week, it will still take us some time. So be healthy and see you next time. I'm going to leave you with some music. See you, folks.